So for 6.2, we're talking about measures of central tendency and dispersion. We're going to mostly talk about measures of central tendency. There are 2 measures of dispersion, and we're only talking about one of them today. So we're going to define all those terms first, and then we'll get into actual practice. So the first one that we need to define is a measure of central tendency. A measure of central tendency is a way to summarize a set of data. You guys actually already know a couple measures of central tendency: mean, median, and mode. Those are your measures of central tendency. Central tendency means like the center of the data. So mean, median, and mode all talk about the center of the data. Okay, so where is the central area? And we'll talk about when using one is better than the other, and so on. Jonah, question?
I was going to ask, is range?
Range is not a measure of central tendency. Range is a measure of dispersion, which we'll talk about in just a second. We also have outliers. So in a data set, if we have a piece of data that is either much greater or much smaller than the rest of the data, it's considered an outlier. So that would be a data value. That is much greater. Or much smaller, or less than other values. In the data set. So what we're going to be doing with our sets of data and looking at mean, median, and mode and our measures of dispersion are constructing line or dot plots. A line plot and dot plot are the same thing. It is a data display in which each mark represents, above a number line corresponds to each data value. So it's also looking at frequency of data. Corresponds to each data value. And we're going to do just a little baby example like we did with the histogram yesterday. So on a line plot or a dot plot, you're going to have a number line. And the little marks are all going to represent your data values. So on our little baby example, we're going to just do 1, 2, 3, 4, and 5. And then for each time that data value occurs, you put either a dot or an X above that value. So let's say, I don't even know what this could be measuring. This could be measuring the number of pieces of candy that you ate today. So let's say 2 of you only ate 1 piece of candy. So you would put 2 X's above 1. Let's say 5 of you ate 2 pieces of candy. So you would put, let's say 4. 4 X's above 2. Let's see if we can get 5 in there. 5, 1, 2, 3, 4, 5, 6. Let's do 6. Ate 3 pieces of candy. Let's say 3 of you ate 4. and 2 of you ate 5. So you put an X or a dot above each time that one occurs. Looking at this data, this is very similar to a histogram, right? Is this data symmetric, uniform, or skewed? This one is symmetric because we have a peak in the middle and it gets lower on each side. So if we were to fold it in half, it's approximately symmetric. Okay? So it's just a different way to represent data. And we can do different things with a line plot that maybe we couldn't look at with a histogram. Okay? So that's the differences there. Our last one is a measure of dispersion. Okay, so if a measure of central tendency talks about the middle of the data, dispersion, which is similar to the word disperse, means how spread out the data is. So it describes how dispersed or spread out the values in a data set are. The values. Okay. We're going to talk about 2 different types of dispersion. Range is the one you should be pretty familiar with. That's one we're going to talk about today. And then tomorrow we're also going to talk about IQR, which is interquartile range. Okay, so just write it down for right now. We're actually going to talk about it tomorrow, but it is considered a measure of dispersion. Okay, so we're going to briefly summarize mean, median, and mode, our measures of central tendency first. And what we're really talking about, I know you guys have done mean, median, and mode. So what we are going to be talking about mostly is when to use which one. So when is mean a better measure of central tendency than mode? Or when is median a better measure? So first we're going to summarize mean, median, and mode. And then we're going to talk about when to use them. So let me really quick black out range because I don't want you filling that out yet. And IQR because we're going to fill that out tomorrow. Okay? So we're just talking about mean, median, and mode right now. So mean is the sum of the data values divided by the total number of data values. Another word for that is what? Average. It is better to use mean to describe the middle of a data set that does not have an outlier. And we'll talk about why in just a second. Median is the middle value in a data set when the values are arranged in order. And then here's like a little parentheses aside. If there is an even number, use the mean of the 2 middle values. So if when you list everything in order and there's an even number, so there's not like an exact middle, you take the average of the 2 middle values. Okay? We use median to describe the middle of a data set that does have an outlier. Okay? So we like mean when there is no outlier. We like median when there is an outlier. And then mode is one that we like to look at, but it's actually in statistics not used very often. The mode is the data item that occurs the most times. So I'm sure you guys remember mode, most. It sounds the same. A data set can have no mode, one mode, or more than one mode. So sometimes a data set might not have a value that occurs the most amount of times. Sometimes there might be 2 values that occur the same amount of times, and so there are 2 modes. We typically use mode when the data is non-numeric or when choosing the most popular item. So if I polled every single one of you and asked you what your favorite color was, we can't really find a mean or median of your favorite color. That's non-numeric data. So we use mode to describe the most popular favorite color. Does that make sense? If I polled whose favorite color is blue, and I counted how many of you have blue as a favorite color, that's numeric data, and we would use mean or median. So numeric data means we're counting how many people like or prefer that thing, or how tall you are, or your shoe size, and we can use mean and median for that. We use mode when the data is non-numeric. What's your favorite color? What's your favorite movie? That kind of thing. Okay, so then if we have measures of central tendency that talk about the middle of the data, it's also useful for us to talk about the spread of the data. How far apart are our data values? What's the difference between our shortest person and our tallest person? So sometimes, or our highest score and our lowest score. So we like to look at the measure of dispersion as well. There are two measures of dispersion that we are going to talk about in this unit. Range and IQR, which stands for interquartile range. We're going to talk about IQR tomorrow because it goes with box and whisker plots. So today we're just going to look at the range. So that IQR part you guys are going to leave blank for today. The range is the difference between the greatest and the least data values, which means we do what? Subtract. And we use it to describe the spread of a data that does not have an outlier. Why do we want it to not have an outlier? Yeah, so let's think about it. LeBron James walks into our room. And who's our shortest person? Is it you? Okay, so I line you guys up by height, and I measure you and write down your heights. And then we do some data manipulating with your heights. But we have Christian and we have LeBron James. I would not consider Christian an outlier because while he is maybe the shortest one in the class, he's definitely not like so short that he would be considered an outlier. But LeBron James is definitely taller than the next tallest person, right? Who would be the next tallest person? Probably Jonah. So if we were to look at the ranges and we subtract LeBron's height from Christian's height, that's going to look like we have a really wide spread of heights in our classroom, right? If we had LeBron walk out and we didn't use his height, the difference between Jonah and Christian would not be as drastic, right?
It would be 7 inches.
Okay. So we like to use range when there are no outliers because the outliers skew our data. So remember when we talked about histograms and if our data looks skewed because there's way too much of one on one side? Outliers skew our data. So if we're talking about measures of central tendency, and I'm finding the averages of everything, and I find your average heights, what is LeBron James's height going to do to the average? It's going to raise it, right? Because we're taking into consideration this really tall person who's not even close to any of the rest of your heights. So the middle of our data looks higher than it actually is. So when there is an outlier, we use the median. Because the middle shows a little bit more accurate where the middle of our data is. So what I did on here, on my notes, I took an arrow and I paired up mean and range. So I did an arrow that went from mean to range to show that those two go together. So when we use when we use mean as our best measure of central tendency, we also use range as the best measure of dispersion because there are no outliers. So the data goes together. Okay? So example 1. I'm giving you 8 bowling scores. from 8 different bowlers, and we're just going to do some data crunching. You may use your phone as a calculator. I want you to find the mean, median, and mode of those scores. I'm going to let you do it on your own because this should be review for you, yes? Okay. What I expect for you to do is show your work. So for mean, I expect that you're showing me all of them listed out, added together, and divided by the total number, what the sum came out to divided by. For the median, to show your work, you need to list everything in order. And then the mode, just tell me what the mode is, okay? Because you're listing them in order for the median, okay? You may work with your neighbor, so to double check your answers. And then together, I want you to answer the bottom question. Which measure of central tendency best describes the score and why? For the mean, this is what I expect for you to show your work. So I want to see it all added up, and we divide by 8. When I add the tops, I got 976. So when you tell me what the sum was, if you messed up on the sum, I at least know that you knew what you were doing. Divide by 8, and I got a mean of 122. When I listed all the data in order, 109 and 113 were both in the middle, so we had to take the mean of those. So your median should be 111. So then the question was, is 189 considered an outlier? What do you notice about the mean? Is it considerably bigger than our median value? Yeah, so what's going on here? Is 189 an outlier? Did it pull our mean higher than the middle value? So 189 is an outlier. If it was not an outlier, mean and median should be pretty darn close because they would both be in the middle. Okay? So because 189 is so much bigger, it pulled our mean over so that our mean was bigger than the median value. Jonah.
Would it be the median be 115? Because 104, you only count that as 1. So
You have to count each data value individually.
wait, because I remember if it's the same number, you just...
So what would be the best measure of central tendency for this one, guys? Median. Why? Because there's an outlier, and what is the outlier doing to the mean? It's making it too big, right? So something in words to that effect. Median is the best measure of central tendency because the outlier is causing the mean to be larger than the median. Something like that. Okay? Finding a data value. This actually comes in handy for you guys. You will do this a lot throughout your academic career. So example 2, we're just going to do it together really quick. Your grades on 3 exams are 80, 93, and 91. What grade do you, I'm going to underline those. What grade do you need on the next exam to have an average of 90 on the 4 exams? So we are missing one data value, right? We're going to call that X. What do we want to do with all of these data values? Average them. So we want 80 plus 93 plus 91. Do we have to include the unknown one? Yep. X divided by how many tests are we averaging? 4. And what do we want our average to be? 90. You guys actually had a question similar to this on a previous test, I think. Or a quiz. Okay, so we need to solve for X, but that divide by 4 is getting in my way. How do I undo that? Multiply by 4. And I'm going to add all those other values in the same step. Are you guys okay with that? Okay. So when I add all of those together, I already did it, and I got 264 plus X equals 360. And then this should be easy. What do you do last? So we get x equals 96. So you need a 96% on the last test in order to get a test average of 90. Okay? Does that make sense? Yeah, because what is this 80 doing to your mean? Dragging it down. So we need a higher score to even it out. Okay? Okay, guys, let's make some line plots. So making a line plot. The results of a survey on the number of televisions in students' households are shown in the list below. So I listed a bunch of data. I want you to construct a line plot of the data, and then we're going to answer the question, is it uniform, symmetric, or skewed? What does that tell you about mean and median? So first we need to determine which values we're going to put on our number line. Our smallest value is 1, and our largest value looks like it is 5. So our number line is going to go from 1 to 5. And then what I want you guys to do also is underline the title. What did we talk about yesterday about titling all your charts? Is it important? Yes. Very important. If you did not title your chart televisions per household, these little X's mean nothing to me. On a test or a quiz, I will not have it titled for you. You have to title it. Okay, so make sure you are aware that the title is there. And then we just count up the frequency of the data. So how many people have only one television? 1, 2. So we're going to do X's, or I like X's. If you want to do dots, you can do dots. Sometimes I have students that do stars. How many households have 2 televisions? 1, 2, 3, 4. So we're going to do 4 X's. You want to make sure that you space them all out pretty evenly. If you squish them all together, it's going to be hard for you to see what the data looks like. How about in 3? How many have 3? 6? 1, 2, 3, 4, 5, 6. What about 4? How many people have 4 TVs? Also 4, 2, 3, 4. So notice that I'm trying to space out my X's the same amount so that they all line up. And then how many people had 5 TVs? 2. Oh my gosh, this data is like perfectly symmetric, right? Okay, so it is symmetric. What does that tell you about the mean and the median? They're going to both accurately represent the data. What else? What is the median number of televisions? Without even counting, what do you think it's going to come out to? 3. If I made you calculate the mean number of televisions, what do you think it's going to come out to? 3. So the mean and the median will be the same because this data is perfectly symmetric. Okay? So in a complete sentence, something like that. The data is symmetric, so the mean and median will be the same. Okay, so question 4, we're going to talk about the range and how that affects our data and when we want to use the range. So here's your problem. The closing price in dollars of 2 stocks for the first 5 days in February are shown below. What are the mean and range of each set of data? Use the results to compare the sets. We're going to do stock A together, and then I'm going to have you guys do stock B, and then we're going to talk about it. So stock A, the mean. You do not even have to reorder them. We just are taking the mean. So 25 plus 30 plus 30 plus 47 plus 28. Divided by 1, 2, 3, 4, 5. That gives me 160 divided by 5, which is 32. So the mean value of stock A is 32. To find the range, we subtract the biggest from the smallest from the biggest. So the biggest value is 47, and the smallest value was 25, which gave us a range of 22. Okay, that's stock A. What I want you guys to do for me is stock B. So the means are the same? Okay. What does that mean? So if we didn't look at the ranges at all, and we got mean was the same, could we really accurately compare these two stocks? No, because the means are the same. So on average, they close at about the same value. But for the range, we got 8. So what does that tell you? Is the range bigger or smaller on stock B? Smaller. So there is less of a difference between all of the values in stock B. So what does that mean? Does that mean it varies more, or does that mean it's more consistent? It's more consistent. It's not as spread out, right? The closing values in stock B are more consistent than stock A, but the means are the same. So if we didn't look at the ranges, we wouldn't be able to compare them at all. But if we look at the ranges, we notice that stock B has less of a spread. So which would you rather own, stock A or stock B? Does anybody want stock A? You have a chance of making more. Would anybody rather have stock B? More consistent? There's pluses and minuses to both. That's the whole point of the stock market. So, and our boys would rather have the riskier one because they could get a higher payoff, right? But those of you that raise your hands for stock B, it's more consistent. So it's less risky. Okay, so there's pluses and minuses for each one. So I didn't really leave a space for that. So let's just make a note of that really, really quick. Stock B is more consistent. Let's just say that. Okay, so note somewhere, stock B is more consistent. Ooh. Okay. Okay, so here's what we're going to do in our last 5 minutes or so. I give you 2 sets of data for quiz scores on a line plot. What I want you to do individually, this is like your exit ticket, and I'll just walk around and double check your answers. Tell me, describe the distribution of the set. Distribution means symmetric, uniform, or skewed. And then tell me which measure of central tendency would be best for each one, mean, median, or mode. And I'll give you a hint, it's not mode. Okay? So your exit ticket is number 5. I'm going to pass out your homework log and your worksheet for homework tonight. And then I'll check your number 5 before you leave. So that's your exit ticket for today.